Hello. So, hi. Today, I would like to talk about this problem here that was given. So this is a dimensional analysis. I'll write it right here. A dimensional analysis. So a DI problem. DA. Sorry. DA problem, which is important in solving things scientifically and mathematically. And DA problems can vary in many forms, but the main goal is to kind of understand and apply different formulas. And one of them today is going to be a conversion factor. Conversion factor. I'll write that for short. Conversion factor. And this conversion factor right here is essential to solving a problem. Like a conversion factor could be anything, solving for anything, but you're trying to unify it. So this is the basic formula, and like let's just say moles. So I'm gonna put moles and then put like kilograms. And there's a number here, number here, number here. This is what we want to solve for. Ultimately, these will cancel out, which leaves you with moles. So that's a basic layout of what a conversion factor is. And it's good that we cover that, because today I'm going to talk about a problem that was given to solve. So you have a bad headache and you go to the store, overwhelmed by options. You look at them, and the first one is Extradine, Advil, and Tylenol. These are the three basic options, and these are just basic infos from it. So just 200 bottles, 200 per bottle, 300 per bottle, 225. And you look at them and you're like, wow. So how can I solve this? The first question you ask is cheapest option, and second is how much costs per molecule. Okay, that's that. And so how I want to solve it, and it's good too that the basic info for the molecules are provided. I don't think I'll be needing them today. I'll probably need them later, but yes, so that's good that it was provided. So I'm gonna show the basic steps of how to solve this for each one of them. So the first thing we do is, and I should also say that we are including info for info based on myself, so my body weight. So what I'm going to do is I'm going to write down the ways to solve them, and I'm going to lay out and I'm going to go through it. I'm going to explain how to solve each one of them. So the first one is acetamol, which is how to solve this per my weight class. So we know that the general basic layout of it is acetamol. You have to take 240 milligrams per 15 pounds. I take that and I times that by my weight. That will give me 1,714.29 milligrams. That's the amount, and that's the amount of like milligrams that I'm not required but recommended to take. So I'm gonna do that for the other ones as well. So ibuprofen and paracetamol. I'm gonna call it Paracet here. So the other one is 113 milligrams per 25 and 102 milligrams per 15. So I'm gonna times that by my weight, and I'm gonna get for it 130 milligrams for that for ibuprofen and 1700 milligrams for paracetamol. So that's the calculation on how much I need to take for my weight. What I want to do next is I would have to calculate the cost of the drug and the cost of it, or the cost of the medicine per how do you say it? Per milligram, right? So what I would want to do is I would want to take the cost per bottle that we showed over at the start of the video, which was $15.51 for Exerdine or acetamine, $15 for ibuprofen, and $14.97 for paracetamine. And we take those and we divide by the given amount per pill. So that's 200 pills right there. That's about, let's say 300, and that's about 500. That's the amount of pills in a bottle, and I will times that by the given milligrams of the of how much they do have per pill. So the given milligrams per pill is, see, you've seen earlier too, and I'll zoom back here. It's that amount right there. So I'm gonna give that amount 200 and 500. I'm gonna times it, I'm gonna divide it. What it's gonna do is it's gonna allow me to know again how much I do have to pay per pill, and you can do it in your calculator too, but I have this amount right here for this, this right here for dollars per milligrams right there. And the last one, dollars per milligram. So that's what I have so far for just generally how to solve it. This will combine with this to give me the answer that I need to know which one is the cheaper one, because what this figures out is, again, this is like a conversion factor. So if you times it, it's basically like me saying, okay, I'm gonna write it down. So it's basically me saying that I'm gonna write out for acetamine here. Acetamine, ibuprofen, and paracetamine, yep, para. So I'm gonna PA for short, okay? I'm gonna write it down like if I'm having 0.00 right there, 0.0003102, I'm gonna times that by the amount that we solved up here, I'm just gonna write that amount down, 1714.29, and that's basically me saying dollars per milligrams, and this is in milligrams as well, so these two will cancel out. Like I gave the example right here, those two will cancel out, which leaves me with the dollar amount for each one of them. In that, the first one, the answer is like 0.532 of a dollar, or if you just move it, that's 53 cents. And the second one, so I'll just write it down real quick. For the second one is 0025. I'll times that by 1130 and 0.00133. I'll times that by 1700 to give me the following result. So second one was 0.2825 and third one's 0.2261. So based on the result so far, that's the amount it's gonna cost per, like, just per pill for my weight. And you can see that this is the cheaper option right here, and this is paracetamol, which is a chemical contained in Tylenol. So Tylenol is the cheaper one, and I'm just gonna write Tylenol is the answer that I need. So once I figure that out, how am I gonna figure out the chemical formula per molecule? So I mean, just looking at the molar mass of each one of them, and each like element in there, like if you look here, and I've already done the math, and it's I just added them, and I just times. Interestingly, aceta and para are the same, so I just need to do para, since para is part of paramol is part of Tylenol. And what I got from that was, so I took that and I laid it out, and I got 151 grams of molar mass, right? Times that by 1,000, I would get 151,000 grams. Okay, to make it grams, times this by 1,000. So that's what I got for that. But we also know that there are about 6.02 times 10^23 per mole. So per that, but it's actually gonna be reversed. So this is how I'm gonna figure out the amount per like molecule. So I've combined it for paracetamol. So the final answer for that second question should be paracetamol is about this 2 times 10 to the 23rd power. All right, that's gonna be divided by 151,000, which if you do it on a calculator real quick, it will give us power 23. It gives us 2.5. I'm gonna say that's times 10 to the power of like negative 27. So then I'll take that and I'll times that by the amount of dollars per milligram that I calculated earlier for paracetamol, which again is right there, 0.000133. I would get 3.33 times 10 to the power of negative 23, because we're going back. So the final answer here, I'll just write it short. I'll just write it. So I'll take this amount and I'll times that by 0.000133. And I would get the final answer of 3.34 times 10 to the power of negative 23. So that's my final answer right there. That's what I would get. So the overall equation gives us the number that it would cost per molecule there, and the cheapest medicine, which again is Tylenol, at around like 0.2261 of a dollar per pill, or 22 cents per pill. So that's my basic way of trying to solve it, and conversion factors factor in here so much because it allows us to kind of transform from one quantity. Like I was trying to find the dollar amount, so I should have put it right here, and so I just got rid of it and I found this. So yeah, that's my video.